Okay, this is a area volume question. It says, a company designs spinning toys using the family of functions, cx square root of 4 minus x squared. Let's see, where c is a positive constant. The area, the figure above, is the region of the first quadrant bounded by the x-axis in this equation. And the spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. So you can kind of imagine if you take this, rotate it, this is something what the spinning toy looks like. Both x and y are measured in inches. Okay, find the area of the region in the first quadrant bounded by the x-axis and the graph of the equation. Okay, so first thing I'm going to come up with is the bounds. I know this is exactly 0, right? And this has to be 2 because if you look at your equation, the only other x-intercept is when x equals 2, then you'll get y equals 0. So that we can come up with. So area is going to be the height of the rectangle, which is basically the equation minus 0. So it go from 0 to 2. And cx square root of 4 minus x squared. That's the height of the rectangle, and the width is dx. Now it does say, so that's the setup. It does say to actually find it. So we are going to go ahead and actually take the antiderivative. I also forgot to plug in the c. It does tell me that c is actually 6. So this should be 6x. Okay, so let's go ahead, and this is a non-calculator problem, so we'll have to do the antiderivative by hand. So you have something raised to a power. So and I'm going to pull this number out in the front. Any numbers I usually just pull in the front. So this is a power rule. So your u is 4 minus x squared. My du is negative 2x dx. That's why you have that extra x there. So if you want to rewrite it, this would be your u to the 1/2. Everything else should be du, but you are missing a negative 2, so that means I also need to divide by the 2. Oops. So really, I'm dividing by negative 20, that reciprocal. So this is what you are integrating. I'll put the bounds in later. So I'm going to add 1, divide by the power, and let's go ahead and clean this up. So this is really negative 2. Replace the u now. And now I can plug in the bounds for x. So if I do that, I get negative 2. Plug in the 2 here. You got 4 minus 4, which is going to be 0. So it really doesn't matter. It's 0 to the 3/2. And then if I plug in the 0, you end up at 4 to the 3/2. And you can leave your answer like this. It's all numbers. Or really, if you clean this up, square root of 4 is 2, and then 2 cubed is 8. So really, this becomes 16. Okay, so this is a 3-point question. 1 point for the setup, 1 point for doing the antiderivative, and then getting to the numerical answer. Okay, part B says it is known that for this function, dy dx, so the slope is given. The radius of the largest cross-section is 1.2 inches. So the radius of the largest cross-section, so it is giving us the maximum. What is the value of b for this spinning toy? Okay, so let's think about what this is telling us. So if this is the largest cross-section, remember a cross-section is just a slice. So it's telling us that this slice, the largest cross-section slice, is 1.2. And we know that can only happen, right? When we talk about maxes and mins, that can only happen when the derivative is equal to 0. So we know this occurs when dy dx has to be 0. We have dy dx, they give it to us. So we know c over 4 minus 2x squared, and dy dx can only be 0 if the top is 0. So I'm going to set the top equal to 0. So divide out the c. I'm going to go ahead and move that 4 over, divide that. And so x has to be positive square root of 2 because notice we're in the first quadrant, so we don't take the negative square root. Okay, so now we have x. So y equals cx. Oops. So now if we plug that in to this equation, we know that square root of 2 c. And if I plug in square root of 2 for x here, this really becomes 4 minus square root of 2 squared, which is 2, so I still have a square root of 2 here. Square root of 2 times square root of 2 is 2, 2c. And what they're telling us in this problem is that the radius, so look back to your picture, right? When we revolve it, this is the radius of that cross-section, the height of that function. So the y value is your 1.2. So I'm going to set the y equal to 1.2, so c has to be 0.6. Okay, this is a 2-point question. 1 point is finding that x correctly, that x is square root of 2 from this idea, and the second point is finding that c value. Okay, lastly, part C. It says, for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? Okay, so we know that the volume of another toy is 2 pi. And we know the volume, when we rotate it about the x-axis, is pi r squared. There is no gap in that region, so we should just be thinking pi r squared and dx. So in this particular problem, so we have pi 0 to 2, r is the height of that function. Oops. It's 4 minus x squared, so it should be pi r squared dx, and we know that this is going to be equal to 2 pi. So this is my setup. So I have to kind of evaluate this whole thing. A couple things I'm going to do is I'm going to square this out first. So this square has to go to the c, it has to go to the x, it gets rid of this square root. So I have that. And I'm going to go ahead and pull this out and just put that c squared out in the front. And then let's go ahead and multiply this out. 4x squared minus x to the 4th dx. So now this is just a power rule, right? Antiderivative 4x squared would be 4x cubed over 3 minus x to the 5th over 5. And let's plug in our bounds 0 and 2. I still have this c squared pi. If I plug in 2, this is 2 cubed is 8, 32 over 3 minus here 2 to the 5th is 32 over 5, and then plugging in the 0 gives me 0. And I want to set this all equal to 2 pi. So lots of different ways you can solve for pi, for the c value at this point. I'm going to go ahead and divide out the pi, get yourself a common denominator, all that stuff. And if you do the arithmetic correctly, you should get to square root of 15 over 32. So it is 2 points for this setup correctly. It is another point for coming up with the antiderivative, and the last point here is setting it equal to 2 pi and coming up with that c value.